In the three types of functions we have discussed yesterday, first type of functions. What is the first type of function?
Sir, one-to-one.
One function. Do you remember the definition of one function?
Yes, sir.
Have you read the definition of one function?
Yes, sir.
Yes. In the textbook, page number 9, the question in the textbook, page number 9, the definition of one function was given clearly. Read that 3 lines. Memorize the definition of one function. Okay, my dear children. Because sometimes you don't know how to solve the question which is based on one function. In that case, at least write the definition of one function, then they will give at least 1 mark or half mark. Okay, my children, that is why I'm forcing you to read the definitions well without any mistakes. Okay. Are you ready to weekly test tomorrow? Are you ready for a weekly test?
Yes, sir.
Exercise 1.1, types of relations. Questions will be given based on types of relations. Okay. Okay, my dear students and son. Right. Now come to the second type of functions. So under this concept, types of functions, we have discussed first type of function, that is one function. What is the other name of one function? Can you tell me, my dear Krupal? Can you tell me the other name of one function? My dear Krupal?
Yes.
What is the other name of one function? Yashwantram?
Injective, sir.
Very good. Okay, my dear Krupal. Have you listened?
Yes, sir.
What is the other name of one function?
Sir, injective, sir.
Yes, remember these points. Remember these points. Question, whatever the question I am asking, what are the answers they are giving? Both are important. Okay, so injective. We have discussed the definition of one function, that is injective function. Now let us discuss the second type of function, that is onto. This is also called surjective. The other name of onto function is surjective. Remember this point, my children. Now come to the definition. What is meant by onto function? What is meant by surjective function? To understand this surjective function, let us take an example. Tell me, my dear Pritika.
Sir.
Tell me, are you watching this screen?
Yes, sir.
What is the function here? What is the name of the function here in this diagram? What is the name of? F is a function. Domain, what is the domain of the function?
X, sir.
X. What is the codomain of the function?
Y, sir.
Yes, very good. Now tell me, Pritika, I connected the elements of the domain with the elements of the codomain. What are the elements of domain here, Pritika?
Sir, 1 to 5.
1, 2, 3, 4, 5. What are the elements of codomain here?
A, B, sir.
A, B. Now, what is the image of element 1?
A, sir.
What is the element? What is the image of element 2?
A, sir.
All of you are listening or not, my dear children? Listen.
Listening, sir.
Now pay attention here. What is the image of 3?
A, sir.
What is the image of 4?
B, sir.
What is the image of 5?
A, sir.
Yes, very good. If you observe this arrow diagram, every element in the codomain, are images of some elements in the domain. Yes or no? No element is left. In other words, every element in the codomain has pre-images. Every element in the codomain has inverse images, at least one inverse image. There may be more than one pre-images, but every element in the codomain has at least one pre-image. Yes or no?
Yes, sir.
Can you tell me, Pritika, what are the pre-images or inverse images of element A? What are the pre-images of element A?
Sir, 1, 2, 3, and 5.
All these 4 elements are pre-images of element A. Now come to pre-image or inverse image What is the inverse image of B?
4, sir.
4. Very good. Only one element. But in this case, there are 4 pre-images are there. 4 inverse images are there. But on the whole, if you observe this arrow diagram, every element in the codomain are images of some elements in the domain. Yes or no? So this type of function is called onto function. This type of function is called onto function. Now I will write the definition of onto function. A function f Now come to this definition, my dear children. You have to memorize this definition well. At least memorize these 3 lines. In the textbook, it was given in 3 lines, the definition of an onto function. Once I read this definition, all of you listen carefully. A function f is a mapping. Previously, I told you how to read this notation. Do you remember that point?
Yes, sir.
Yes. A function f is a mapping from x to y, is said to be onto or surjective if every element of y is the image of some element, at least one element of x under f. That is, for every y belongs to y, there exists at least one element in x, x in x, such that f of x is equal to y. Okay, my children, all of you read this definition one by one. You should memorize this definition. Preetika, read this.
Yes, sir.
Read this definition.
A function f is a mapping from x to y is said to be onto function or surjective if every element of y is the image of some element, at least one element of x under f. That is, for every y belongs to y, there exists at least one element x in x, such that f of x belongs to y.
Yes, f of x is equal to y, not belongs to m. F of x is equal to y.
Okay, sir.
Okay. Right. Now, Grayson, read this definition.
Yes, sir. A function f is mapping from x to y is said to be onto or surjective if every element of y is the image of some element, at least one element of x under f. That is, for every y belongs to y, there exists at least one element x in x, where f of x is equal to y, such that f of x equals y.
Very good. Now come to Joseph. Read this definition once.
Function f. Sorry, sir. I'll start again, sir. A function. Okay, sir. A function f is a mapping from x to y is said to be onto or surjective if every element of y is the image of some element, at least one element of x under f, such that for every y
is not the, such that is I dot e stands
okay.
for that is.
Okay, sir. That is for every y belongs to y, there exists at least one element x in x, such that f belongs to x is equal to y.
F of x is equal to y.
So, okay, sir. F of x.
Okay. Learn this definition well. Now come to Jerome Jesliras. Your turn. Read it once.
A function f mapping from x to y is said to be onto function or surjective function if every element of y is the image of some element, at least one element of x under function f. That is, for every y belongs to y, there exists at least one element x in x, such that f of x is equal to y.
Very good, Jerome Jesliras. Now, Blessina, read this definition. Blessina.
A function f is a mapping from x to y is said to be onto or surjective if every element of y is the image of some element, at least one element of x under function f. That is, for every y belongs to y, there exists at least one element x in x, such that f of x belongs to
f of x is equal to
y.
F of x is equal to y. Now Janani.
Yes, sir.
Read this definition.
Okay, sir. A function f is mapping from x to y is said to be onto or surjective if every element of y is the image of some element, at least one element of x under f. That is, for every y belongs to y, there exists at least one element x in x such that f of x is equal to y.
Yes. Staines Johnson. Staines Johnson.
Yes, sir.
Read this definition.
A function f H is a mapping of y said to be onto or surjective if every element of y is the image of some element, at least one element of x under f. That is, for every y belongs y, there exists at least one element x in x, such that f of x is equal to y.
Very good. Next, Krupal. My dear Krupal, read this definition once. Krupal,
Yes, sir.
read this definition once.
A function f is a mapping of x to y
Mapping
is said
from,
to
not Krupal, stop. F is a mapping from, not mapping of. Okay,
be yes, sir.
read it correctly. F is a
F is a
mapping
mapping
from.
mapping
Okay,
from x to y is said to be onto or subject to is every element of y is an image of some element, at least one element of x under f, that is for every y. Sir, what we call that?
belongs to,
Y belongs
belongs
to
to.
y belongs to y. There exists at least one element x in x.
Krupal, still there is a definition.
Yes, sir. Such
Uh,
that f of x equals y.
yes, very good. Kevin Paul,
Yes, sir.
once read this one.
A, a function f is a mapping from x to y said to be onto or surjective if every element of y is the image of some element, at least one element of x under f. That is, for every y belongs to y, there exists at least one element x in x, such that f of x equal to y.
Very good. Yashwantram, read once. Read this definition once. My dear Yashwantram,
A function f is a mapping from x to y. It's said to be onto or surjective if every element of y
image.
is the image of some element
At least
one element of x under f that is, for every y belongs to y, there exists at least one element x in x such that f of x is equal to y.
yes. This is a definition of onto function. So just by observing the arrow diagram, you can easily identify it is an onto function or not. Suppose, see this example. Now, okay, are you watching this screen? All
Yes,
of you are watching this screen? Yes. What is the name of this function here for this arrow diagram?
G, sir.
G, sir.
G. Yes. What is the domain of this function, my dear Krupal? Krupal, what is the domain of the function G? Krupal. My dear Krupal.
Yes, sir.
Krupal.
Yes, sir.
What is the domain of this function G? What is the domain?
Sir, A, sir.
Yes, very good. Set A. What is the codomain of this function?
Sir, set B, sir.
Very good. What is the image of 1 here?
Image of 1 is Z, sir.
Image of 2?
Sir, 2 is also Z, sir.
Image of 3?
Sir, 3 is Y, sir.
Image of 4?
Sir, Y, sir.
Image of 5?
Sir, for 5 also Y, sir.
What are the elements in the codomain? What are the elements of codomain?
Sir, X, Y, Z, sir.
X, Y, Z. Every element in this codomain are connected with at least one element in the domain.
Yes, sir.
Every element in this codomain, are connected with at least one element in the domain.
Sir, can you repeat?
Every element in this codomain has a pre-image.
Yes, sir.
Yes. What is the pre-image of X? Tell me. What is the pre-image of X?
Sir, not there, sir.
Then what did you tell here? Previously, what did you tell? Every element in this codomain has a pre-image.
Yes, sir. Forgot it, sir.
Forgot. I'm not asking the definition from the textbook. Observe this arrow diagram and tell me the answer. That's all.
Yes, sir.
There is no need of forgetting. Here, just observe the diagram and tell me the answer.
Okay, sir.
So every element in this codomain are connected with at least one element in the domain. Every element in the codomain.
Yes, sir.
Again, you are telling yes, sir. X is connected with any element?
No, sir. No, sir.
You are telling yes, sir. Sometimes you are no. There is no confident answer. There is no confident
Not
answer.
having, sir. Not having any element, sir.
That only I am asking. Every element in this codomain, every element, listen this sentence carefully. Every element in the codomain does not have at least one premise. Here X is also an element of this codomain, but it has no at least one pre-image. It doesn't have at least one inverse image. Yes or no? So here we say that G is a mapping from A to B. See this point, my dear children. Therefore, G is a mapping from A to B. G is a mapping from A to B is not onto, because the element X, the element in this codomain X, in the codomain B does not have at least one inverse image in the domain A. In the domain A. That is, we can write this sentence like this also. X in the codomain is not an image of any element in the domain. This is the reason. This is why this function is not surjective. Understood this point, my dear children? Got this
Yes,
point?
sir.
So, this is the main condition. Every element in the codomain should have at least one preimage. Okay, my dear children?
Okay,
Yes,
sir.
sir.
All of you memorize these 3 lines in the textbook, page number 9. The page number 9, onto function definition was given. You can follow any method by writing that definition 10 times or 15 times or 20 times, as many times as you can write, until you become perfect in that definition. Until. Okay, my dear children. Now come to 1, and onto. Next, third type of function. 1, and onto. Next type of definition function is 1, and onto. This is also called bijective. This is also called bijective function. A function f is a mapping from x to y is said to be is said to be 1 and onto. This is also called bijective. If f is both f is both 1 and onto. This is the third type of definition, third type of function. So, bijective, this is also called 1 and onto. A function f is a mapping from x to y is said to be 1 and onto, or bijective if f is both 1 and onto. This is a third type of function. The entire exercise is based on these 3 types of functions. Okay, my dear children.
Okay, sir.
Sometimes they will give a function and they will ask you check whether the given function is bijective or not. In that case, we have to check whether the given function is satisfying the conditions of 1 function and onto function. If the function satisfies both conditions, then the function is said to be bijective function. If function does not satisfy any one of these conditions, any one of these 2 conditions, then the function is not said to be bijective. Okay, my dear children.
Okay, sir.
Right. Now, Come to the exercise sums. Once read this definition. Once all of you read this definition. Preetika.
Yes, sir. A
Read
function f is mapping from x to y is said to be 1 1 and onto or bijective function if f is both 1 1 and onto.
Very good. Grayson. Next,
Yes,
Grayson.
sir. Yes, sir. A function f is a mapping from x to y is said to be 1 1 or 1 2 or bijective function if f is both 1 1 and onto.
Next, Joseph. Joseph.
A function f is a mapping from x to y is said to be 1 1 and onto or bijective if f is both 1 1 and onto.
Next, Jiram Jasniraj.
A function f mapping from x to y is said to be 1 1 function and onto function or bijective function if f is both 1 1 function and onto function.
Very good. Next, Blessina. Blessina.
1 and onto bijective. A function f mapping from x to y is said to be 1 and onto for bijective if f is both 1 and onto.
Next, Janani.
A function f is mapping from x to y is said to be 1 1 and onto or bijective if f is both 1 1 and onto.
Next, Staines Johnson.
A function f is mapping from x to y is said to be 1 1 and onto or bijective function if f is both 1 and onto.
Next, Krupal. Krupal.
Yes, sir. Yes, sir.
Read.
A function f is a mapping from x to y is said to be 1 on 1 and onto a bijective if f is both 1 on 1 and onto.
Next, Kevin Paul.
A function f is a mapping from x to y is said to be 1 1 or onto or bijective if f is both 1 1 or onto.
And last, Yashwantram.
A function f is a mapping from x to y is said to be 1 on 1 and onto or bijective if f is both 1 and 1 and onto.
Okay, my dear children, this is the definition of 1 1 and onto. Let us take an example by arrow diagram. Let us check whether the given function is 1 1 function and onto function or it is a bijective function or not. Now tell me, is this function, which type of function this one? Is it 1 1 function? Is this function 1 1 function? Anyone can tell this answer?
Yes, sir.
Is it 1 1 function?
No, sir.
Grayson? Is it 1 1 function?
No, sir.
Joseph?
No, sir.
Jiram Jasviraj?
Yes, sir.
Is this function 1 1 function or not?
Sir, it is not 1 1 function, sir.
Blessina?
It is
it
not
1 1
1 1, sir.
Huh?
It is not, sir.
Janani? Janani?
No, sir, it is not one-one function, sir.
St. Johnson?
No, sir.
Krupal?
Yes, sir.
Is it a one-one function or not?
No, sir.
Kevin Paul?
No, sir.
Yashwant Ram?
No,
Yashwant
sir.
Ram?
No, sir.
Is it one-one function or not?
No, sir.
Yashwant Ram?
Sir, it is not a one-one function, sir.
Why it is not one-one function? Tell me. Yashwant Ram?
Sir, the A is not one-on-one mapping from A to B, sir.
Tell me the reason clearly. Tell me the reason clearly. Can you tell me, Kevin Paul? Can you tell me the reason why this is not one-one function?
Sir, both 1 and 2 has the same image.
Yeah, very good. Both elements, 1 and 2, these are two elements are distinct elements in the domain, but these two distinct elements have the same image. That is why this is not one-one function. Now, is it onto function or not? Is it onto function, Preetika?
Yes, sir.
Is it onto function, Grison?
Yes, sir.
Joseph?
Yes, sir.
Jerome Jasliraj?
Yes, it is, sir.
Tell me the reason, Jerome Jasliraj, why it is onto function?
Because codomain has the image, sir.
Codomain?
Has a pre-image.
Not codomain. Don't say codomain. Every element in the codomain. How many elements are there in the codomain?
X.
Only one element. Only one element. Only one element, namely X. Only one element is there. It has a pre-image. Yes or no? What are the pre-images of X, Blessina?
1 and 2, sir.
1 and 2. So every element in this codomain has a pre-image. So this is called F is a mapping from A to B. Is not 1-1 because this is the reason. F is a mapping from A to B is not 1-1 because distinct elements 1 and 2. Are you all watching the screen, my children?
Yes, sir.
These two are distinct elements in the domain have the same image X in the codomain B. That is why it is not 1-1. But F is a mapping from X to A to B is onto. Because listen carefully, my dear children, but F is a mapping from A to B is onto because every element in the codomain, namely x. Here we have taken only one element, x has at least one pre-image in the domain. That is why it is called onto function. Okay, my dear children. Now the time is 3 past 18 minutes. Now you can leave the meeting. Take rest. Take care of your
Thank you, sir.
Thank you, sir.
Stay safe. Stay at
Thank
home.
you, sir.
Use
Love
mask.
you, sir.
Thank you all. Thank you all. But all of you watch the video again. All of you watch the video again.
Okay, sir. Thank you, sir.
In the evening time, instead of watching the TV programs, TV programs, please watch the video again. Okay, my children.
Okay, sir. Thank you, sir.
And submit your notes. Submit your classwork notes. Submit your classwork notes regularly.
Okay, sir.
Yes. I will post these notes.
Sir,
Yes, my dear Pritika, tell me.
sir, I have doubt in first sum of exercise 1.1, sir. Fifth subdivision.
In 1.1 exercise.
First sum, sir. Fifth subdivision, sir.
Okay.
Sir,
After 4:30 or after 5,
Okay, sir.
call me and I will clear your doubt. Okay.
Okay, sir. Thank
After
you, sir.
5:30. Sorry. After 6 today. After 6, call me. I will clear your doubt. Okay.
Okay, sir.
Yes.
Thank you, sir.
Okay.
Sir,
Yes, my dear Joseph.
sir,
Tell me.
can you tell me the last sentence, sir? That one, sir.
Today.
Yes, sir. In the last sentence, sir. Like while you were writing in the between, like the screen got disconnected, sir.
Yes, yes, I observed that one. I will post this one. I will post this as I'm posting the classwork notes daily. I will post this one. Don't worry. Okay.
Okay.
You can find that last sentence completely, clearly. Okay.
Okay, sir. Fine, sir. Thank you, sir.
Okay. Are you writing the classwork notes, Joseph?
Yes, sir.
Submit your classwork notes regularly. Okay.
Yes, sir.
And watch the video also. Watch the video also completely. Not only for 5 minutes or 10 minutes. Okay.
Okay, sir.
Okay. Carry on.
Thank you, sir.
Okay. Thank you. Thank you.